Here we have Tracing Code Worksheet 2, which is probably the most important worksheet in the whole Visual Basic course, because this is the worksheet where you learn how a computer thinks. You see, computers always execute code. They don't have brain cells like we do. And the code is typed out line by line. It's been done that way for 50 years of computer science. And here we have a little code segment, and we're going to trace this code. That means go line by line and keep track of what happens, tracing code. And the first line of code, constant price per donut as double equals 0.50. I don't have a column over here, so there's nothing really to fill in. Just make a mental note that price per donut is 50 cents. Next, discount. Just make a mental note that discount is a constant. That means it can't change. It's going to be $2.50. So I just check mark that I've already executed that line of code. Now I'm down to this line of code. This is a declaration statement. We are declaring a variable named numDonuts. It can change, and it will change later in the program. It starts out at 0, so let's put a little nice 0 there. Please print small and neatly, because a lot of times you'll end up with lots of numbers here, and when I grade this, I don't want to have trouble reading it. Just for the record, donuts has to be a whole number. It was declared with the data type integer, which means donuts can never be a decimal number. And that makes sense, because no donut store would sell 1.2 donuts or 0.33 donuts. It just doesn't make sense. So we did that line of code. Next, total cost, another variable. It's a double though. Now it starts at 0, so put a 0 there, but it can end up being something like $19.99. So we check that off. Notice how the programmer put a nice blank line here, because we're done with the declaration statements, and now we're ready for the hardcore code. This is the calculation area where it gets tough. Let's trace that code. This line of code. This is called an assignment statement because it doesn't have dim in front of it, but it is doing something with an equals. Assignment statements always assign a number from right to left. We're assigning the number 5 into the variable numDonuts. So please reflect that over on your scratch paper by putting a single slash there and putting a neat 5 under it. Do not erase and do not scribble out. I like to see, I want to see the old number in case you're off by 1 or something. I want to see how close you were before you got off track when you do complicated questions like this. Okay, we did that line of code. We're done with that. Next, now the real hard line of code. We got to follow, please excuse my dear Aunt Sally, order of operations. We have a star and a subtraction. So let's do the multiplication, the star first. Well, what is this? numDonuts. Well, go look. numDonuts is currently 5. So beginners should put a little 5 there. I know eventually you can do this in your head, but just bear with me here. This is early in the school year, your first computer code class ever. Don't worry, it'll get easier. Price per donut. Price per donut is the constant. It was 0.5. Now we do that multiplication, and that comes out to 2.5. So I just put a little 2.5 above the star. That's the way I do things, as if I were a beginner. If you need a calculator for that, go ahead and use it. But on tests, I don't allow students to use a calculator for easy stuff like this. I'm just warning you. So that's that. Now, we're not done yet. We have this minus discount. And discount happens to be $2.50. So let's do that subtraction there. 2.5 minus this 2.5 that we have left, because this is already done here. We did that. 2.5 minus 2.5 is 0. So this whole right-hand side of the equal symbol simplifies, evaluates to a 0. And that 0 needs to be plugged in to the variable total cost. Because I stress, assignment statements always work from right to left. And therefore total cost, over here, you know, where we're keeping track of it, it just went from 0 to 0. I still reflect that on my scratch paper. Even though it's kind of silly to cross out a 0 and put a 0 there, I'm very, very precise when I do these things. And it might not make sense, but that's the way it is. Don't question the person who made the worksheet. I sometimes have logic mistakes, and you'll get it right, even if you follow my logic mistake. Anyway, we're done with that line of code, and we're now ready for the last line of code here. Well, we have a dollar sign. It's in double quotes because a dollar sign as a string, as a piece of text, has to have double quotes around it. That's the way it is. Then we have this plus, which is kind of interesting because I never thought of adding a dollar sign to something, but that's the way it is. Then total cost is currently 0. So I plug the 0 in here, but then I see this command called str, which I just read in the lecture notes. It means to turn a number into a string, which is just a fancy way of saying text. So in other words, str, it puts quotes around that 0. So you might want to rewrite it as a 0 with quotes around it. And now we have to deal with this plus. This plus is really what you might have read. It's called the concatenation operator. And what it does is it glues two strings together, two pieces of text. So all of this goes together as simply a dollar sign with a 0 right next to it. And all of that has one outer set of quotes around it. I just didn't have room to put it down here. So all of that simplifies to this. And what happens with it? It plugs in from right to left. And what's it plugging into? It's plugging into not a variable. This is not a variable because otherwise it'd be up here in the dim area. It's not a constant because it's not all uppercase letters, and it's not up here as a const. No, you just have to assume that there's a label somewhere on the screen that's named LBL total cost. And that label, it always has a text property. You know how that works? Well, that label now will show a $0. So here's my label actually on this worksheet, I guess. I should have put it right there. Your answer is $0. You don't have to put the quotes around it unless you really want to. I don't care either way for this particular worksheet. So let me clean that up a little bit. Your final answer is like that. It doesn't make sense, but that's the way it is. Maybe this store is giving away free donuts as long as you buy like 5 donuts or less. Maybe it's a free donut day. Don't question the logic of the code. On the AP exam that you might take next year, they purposely put dumb things in to see if you follow the code or you follow your own mind and say, well, this is the way it should be. They get you if you fix their code. They don't want to see that, especially on multiple choice questions. They try to trick you.
Why would they, you think they want to do something that's realistic?
Great question, Leah. You would think that they'd want realistic answers. Well, people that code, they often make mistakes themselves. So the AP exam in computer science is really a test to see if you can fix your own mistakes someday. So they make mistakes as if you made them, and it's your job on the test to find out where the mistakes are. Sometimes they do give you questions like you just said, but sometimes they purposely put mistakes. And that's what a good AP computer science test taker can do. And that's what makes somebody a good lawyer, a good doctor, a good professional in any critical thinking job. You're the person who finds the mistakes. Code executes line by line, and these assignment statements work from right to left. So follow those principles, and this whole school year will be a breeze. The rest of this is homework. I will hit the highlights here in this video to see if there are any other tricks that I did not warn you about. In number 2, you're supposed to assume that the number 10 is plugged into this text box at the appropriate time. So that 10 with a set of double quotes around it is what's typed into the text box. And then the val strips the quotes off so that the number 10 plugs into numbooks. So there's a little hint as to what happens at some point during that code segment. The rest of it's fairly easy in my opinion. Number 3, you're supposed to assume that the number 18 is typed into that text box. So think of that as an 1-8 with double quotes around it. Notice how I did not say 18. 18 is the number, but 1-8 is called the string way of saying it. kind of like 19610 is a local zip code here in Pennsylvania. But if pronounced 19,610, then somebody means the number, which is without quotes. Okay, so that was number 3. You have to plug a 18 in there. And number 4, I think that's fairly obvious. I'll just give you a hint. Follow PEMDAS in number 4. Exactly. Good luck, and we'll see you tomorrow with answers to that worksheet.